Hello, my name is Jason Belden, and this video is how to use a multimeter basics. We will be using one digital meter multimeter and one analog multimeter. The reason we're doing this today is there's a lot of novices out there in the green energy market, like in wind and solar. So using this meter will actually help them maybe figure what they want to do with their house or projects for the green energy. So the first thing is safety. Always read your safety precautions. If you buy a multimeter, read what it says, because there is a lot of precautions on it, and pretty much follow what it says. Alright, first thing we will do is list our materials that we're going to use today. What I'm using today is, this is an industrial digital multimeter because of LED display, and you can get these for about $100. They ain't that expensive, but the ratings on them a little higher, so it makes them safer for a higher voltage, because this one's rated for 1,000 volts. This other meter I got here is an analog meter, and this is where the needle moves with it, and you actually see the needle move. So that was the difference between digital and analog meter. And this one's only rated for 600 volts. Next thing I'm going to do is a pair of side cuts just to cut a wire or clothes hanger. I'm using a screwdriver, a regular battery, any kind of battery work, but I have a AAA here just to go through the basics, and a clothes hanger. And I did bring a basic fan too, which we will display why I'm using this next. Okay, so the first thing we want to do is check resistance. That'll be the first setting on both. So if you come over to the meter, there's a dial usually on it, and there's an ohm. You're going to flip it to ohms. And it's going to read OL, which means open, and that's electrician's term mean open. So the leads are actually open. If I was to touch them, that's called a dead short, and actually it'll read 0 or 1. So first thing we want to do is I'm going to take this clothes hanger. So if I was on one end of the wire, which this is make sure you do this on a non-energized circuit. That's why I grabbed the clothes hanger. So this would be if you put a windmill or some wiring for your solar panels, you can check, if you have a broken wire. So if I was to take one end of this clothes hanger to the other, it's connected, it's one loop. So this is where the side cuts come in. So if I was going to cut there and there, well, now you got an open, until the circuits touch. I can get them. But you might not be able to. No, because of the metal on it, because the metal's resistance. Alright. That'd be completed circuit again. So, if we were to do this with the digital multimeter, you're going to put your setting probably on resistance, and there's multiple on a digital meter. So if I touch it, you actually see the needle move to 0. That's your dead short. That's your open, which they got an infinity symbol on here for open. And then that would be the same thing. If I was to touch this to get a good connection on this, there it goes. And then you go back to the open. So that's kind of what resistance is. It's the resistance of your metal, and it should pick up either if your resistance of your metal lets electricity flow easy, it's going to go down lower. If it don't let, like wood, if I was to put this on wood right here, it's open because it don't let electricity flow through it easy. So that is resistance. Let's do voltage. Our next setting on our meter is voltage. Now take caution on some of these meters. Like this meter here is AC, DC, it detects both. It'll start out as AC. So if I take my battery, and this is a 1 volt battery, and it'll read 1 volt DC. It'll switch it automatically. And if I switch the leads, like put the black on the positive it won't hurt nothing, but it'll just read backwards on the meter. You see, it reads minus 1 volt DC. That's telling me the leads are backwards. That's all it's doing. And that would be the same way for this meter here. I'm going to put it on, see on this one you got to select DC volts. And then you want to go to the smallest scale, because I know how low voltage this is. Just 2.5. And it should read 1 on this. Whoa. This meter. There it goes. Whoops. Which is your DC volts right there, which is 1. It's reading a little bit 1. Well, it's a 2.5 scale, that's why. So now this is where you want to stay cautious. If you ain't sure what you're doing, please don't do this. All right, since we got voltage, I put this on a 250 volt scale. Now you get these meters like at Home Depot or anything, and you can probably order this one online. It's real cheap. This one has a low rating, so if you wanted to check voltage in your house to make sure the circuit's dead, this would be set on 250. And it actually reads 120 volts in the house. Now I'm gonna do the same thing with the digital meter here. You put it on voltage, it'll detect, this one's automatic, so it'll detect it. 123 volts. And it actually gives a red light on it when you're on it, saying it's hot. So, you got voltage and resistance. What I'm going to check next is amperage, which you got to be you should be certified to do this, and make sure you read up on the safety precautions on amperage. So what I'm going to do is, first thing I'm going to do is leave this on voltage. And you'll see this meter go out once I kill the breaker. We're going to do that first. Is that out yet?
No.
Is that out?
Mm-mm. There we go.
Out?
Mm-hmm.
That's out? Alright. So, now the thing with this meter is now if you wanted to work on your house circuit, I just killed the power. So this is where your screwdriver comes in. And the circuit is dead, which we just checked off our meter. Alright, so you got 2 leads and a ground. What we're going to do is, we're going to plug this fan in. I'm going to leave the circuit off until I plug this fan in. I'm going to leave this out. I remembered what breaker I killed too. I'm going to turn it back on. This fan should work, which it does. We'll put it on the highest setting. On this is a safe way of doing this. This is all insulated for amperage. All I'd have to do is go like that. Should be about 1 amp, 0.9. That's how many amps that fan's pulling. So if I turn this off, it should go down to nothing. So the amperage can be checked a different way on this meter, which I suggest you don't do this unless you work with electronics, and that is actually putting it in the circuit. We are not going to do that with this, because I mean, you can do it, but you're actually gets a little dangerous, because if you got your leads hooked up wrong here, this meter will actually blow up. But there is resistors in here to pop before that happens, but there's always that chance. So make sure you read all your instructions before. And this I am not going to demonstrate, because most homeowners for the basic use are going to use voltage and resistance and maybe a digital meter for amperage, especially if they're putting a solar panel or a windmill up. All right, so for the basic use of the meters, it should be your resistance, and your resistance should never be checked on a live circuit. And then you want to check maybe your voltage, and your voltage, make sure you have it set on the right, either AC or DC, and the right setting. According to this meter's automatic. So, and amperage, this meter would be the best for amperage. It's only a $100 meter, but it's actually a pretty good industrial rated meter. So, if you were doing your work on your house and wanted to basically check everything, I would suggest use this, a digital meter that automatically changes. All right, thank you and goodbye.